Hello, and welcome to the third webinar of a series on the topic Roadway Designer for Power Geopack. This webinar will focus on superelevation in Roadway Designer. My name is Kathy Kassar with MDOT Engineering Support Services. The future webinars in this series on Roadway Designer will cover driveways and ditches, template transitions, intersections and gores, and creating surfaces and plotted cross-sections. Before attempting to set up a corridor, it is necessary to know how to import the DDB, TIN, geometry, and plan view graphics into Corridor Modeler. We are going to be focusing on Roadway Designer itself in this series and not the importing process. However, if you are looking for some tips and tricks on importing graphics in Corridor Modeler, please see Part 1 of the existing template series. It is also necessary to know how to build a template. Please see the previous webinars on building the proposed template for Roadway Designer for more information on how to properly construct a project template. What you should have before you begin to work with Corridor Modeler and Roadway Designer are the following: a Geopack PRJ file created and opened, a working alignment definition defined and in use, a Corridor Modeler RDP or batch load file created and loaded, imported horizontal and vertical geometry and plan view graphics, and lastly, a project template created. Superelevation. Within Roadway Designer, there are a number of different ways to get the base superelevation data into the program. You can still use the superelevation shapes and import the input file into Roadway Designer if you still prefer that route. Roadway Designer does have several built-in options that run a wizard to add superelevation. It is necessary to either import an input file or run a wizard to use the superelevation tables provided in Power Geopack. It is also possible to manually create superelevation control lines and apply them to the various portions of the template based on hand calculations. Superelevation data can also be imported from Excel or ASCII files if they are formatted correctly. The choice is really up to the individual with respect to comfort and how much automation is desired. Personally, I have not had much luck getting the output from either the old superelevation shapes and input files nor the superelevation wizard providing me with the output that matched my hand calculations without requiring any editing. I can tell you that we are working on trying to resolve that issue in the SS3 release, and that the process for entering superelevation data in SS3 is a hybrid of both the old shape method and the new wizard method. Once you have some superelevation control lines, they can be edited in a number of different ways, either as a curve set, as the entire curve and transitions in one dialog, or as individual points in a superelevation diagram. Either way will work and depends on user preference. With respect to subgrade and shoulder transitions, I have had little luck getting the shoulder rollover locks to match the MDOT method for superelevating the shoulder components. Typically for shoulders and subgrade, I create a single superelevation control line specifically for the shoulder and or the subbase and apply them to template points in the point control dialog manually. So let's pop out to Power Geopack and take a look at the superelevation dialog in more detail. Alright, so we're going to jump right into Roadway Designer and take a look at the superelevation dialog, and again we'll go down to the superelevation display mode. Just a few things to note about this display mode. Again, we have the various views as in the normal view that we see in the dialog. However, if you right click in the two windows on the right, you get a lot of options that are going to be available to you that you don't get anywhere else. This method of context-sensitive menus and navigating through the dialog is going to be commonplace in SS3. So try and get used to right-clicking on those windows to find the tools and options. So in the bottom corner, which is the bottom right corner, which is our superelevation diagram, if I right-click, you'll see there's a number of different options in here, and in the upper window, which is going to be the profile window, you'll see that there's again a whole display list of different points. As I scroll across, you'll see that I get a number of different points in this upper right window, or a bunch of different lines, and these are the superelevation control lines essentially of all the points in the template. This is every point that we have in the template and how it is moving with relation to the profile. In most cases, all we really want to see are going to be the center of or the crown, our point of rotation, and the edges of pavement. So I'll go ahead and put that in and clean that up. In the upper left side is our plan view. And what we get here is a lot of color variation, and this is very, very specific to kind of give us an indicator of what's going on with the various slopes. And we can see that down here in the cross-section view. You can see the various colors. Alright, some things to pay attention to. Again, the flatter the slopes, the lighter the color. 0% slopes are always going to be white in color. All 2% slopes that are going to be tipped toward the left are yellow, and all 2% slopes tipped toward the right are in green. Colors will darken up the color palette as the slope increases. So all components tipping to the left will move toward a deep red as the slopes increase, and all components tipping toward the right will move toward a deep blue as the slopes increase. This is just one visual tool that can be used to quickly evaluate the superelevation on a project. Okay, so we're going to add superelevation to this project using there are several. There's superelevation. You have the table method, the AASHTO, and the fixed length. We're going to use the table method. They all will provide with the basis of the superelevation data, but for in this case, I'm going to go with just the table method. Again, to pick your table, you can go out to your M drive and you would copy your superelevation tables that you would need. You can put them here in your project folder. You can also just use the ones on the M drive, but I find it handy to keep the table with you that in your project folder. So we're going to head and grab the 40 mile an hour. Again, the runoff percentage, since we do the 2/3, you can actually put in 2/3 if you in that way, and you want to interpolate always from the values on the table, and that way you'll get those interpolated values. I normally just leave it on the runoff, and then you can load the values from the table, and you'll see that it tells you the various superelevation required based on that table, and the of course the normal crown sections and the superelevation information is all here for you. Again, you can check this against your hand calculations and make sure that these numbers are matching what you have come up with in your hand calculations. And I will go ahead and hit next. Now, one of the things that's often overlooked is that of course you need sections, but not a lot of people know what a section actually means. Alright, typically the concept of a section would be in a typical roadway we probably just have one section. That's one road, that's one single undivided roadway with the constant design speed. That's basically one section. Alright, now if you had a divided roadway where you have both sides of the roadway in one template, then you have to have at least two sections, one for each side of the template. And I say at least two because the other use of a section is to apply a different superelevation design speed or application to the same corridor. So if the design speed changes, you can get the program to automate the input process by doing a different section for specific station ranges. So it allows for some additional automation of the input process instead of just creating one table and then hand editing all of the superelevation rates and transitions for the areas with different design speeds, lane widths, etc. Alright, so we'll enter section 1, and of course you can simplify the list so you only get the upper backbone points. From the crown, again using the radio button, I'll pick my crown location, left range point, right range point, and of course my rotation is happening from the crown point. Number of lanes 2 or 4 really has to do with whether or not you were talking about a divided or an undivided roadway. In the case of an undivided roadway, then it's typically your 2. If you have a divided roadway, you would hit the 4. Alright, again, you can pick the station ranges for your section if you want your section to stop and start in certain areas because of varying design speeds. Alright, in this case I'm going to go ahead and leave it uniform. Alright, so then it gives you the option to take a look and edit any of these if you like. You can edit the width, you can edit the entering and exiting stationing. It's kind of hard to really understand what you're editing in these cases in this particular dialog, so I typically will not do my editing here. I'll hit next. You'll see that these are the superelevation control lines that it's going to create. You can edit the names of these if you wish, so they're not quite so long, and you can see them a little easier. The pivot point is the crown joint, and then you're telling you that which point edge of pavement is going to be rotating and the initial cross slope. You'll hit finish, and you'll see that it has now populated the lower right hand screen with our superelevation diagram for this project, and our cross section is now superelevated in the lower left. Okay, so if we look at the point control menu, you'll see that it has automatically entered my 2 superelevation control range points, those edge of pavements right and left, the entire station range of the project. The mode is, of course, a vertical mode, and it's a superelevation, and the superelevation control line that is in play. All right, this happens automatically when you assign the superelevation. To edit any of these superelevation points, you can double-click on any individual point, and it will pull up an editing dialog box. All right, it tells you that it's in full super. It gives you an option on how it's constrained. All right, that means that it is locked in some way to another point within the superelevation dialog. All right, the station range, and again, as I said, the type. To get a better look at what the constraints actually mean in a curve set, we'll do a right click in this lower window and we'll do Edit Curve Set Stations. With the Curve Set Stations dialog box, you can see an entire curve as a whole. All right, we can scroll through and see any of the curves that have had superelevation applied to them. All right, we'll go back to that first one. With the constrained, what this means is any edits that I have are not going to be properly reflected unless I have unchecked these constrained boxes. All right, now I can go ahead and freely edit this particular superelevation curve. All right, if I leave the constraint checkboxes on, they don't work. Now, if I want to add various elements, I want to be able to see where normal crown is, and you hit the plus button on the top and the plus sign on the bottom, and you'll see that I have added various different parts of the superelevation. Now, if I continue to add this, I will go into the next curve. All right, which typically you don't want to try and edit all of your curves in one dialog. So this allows me to look at normal crown and make my adjustments to the superelevation, cross slope, the stationing, the transition lengths, and those types of things. Again, I must uncheck the constrained options in order to be able to have my edits be saved. All right, if I had multiple sections, I could select the different sections and again do my curves one at a time and scroll through and make all of my edits this way. This is one way to do your editing of your entire curves. And again, if you have your superelevation done in a spreadsheet, which most people do, then you know all of these particular stations and you can go ahead and enter them appropriately. Now, what you don't have in here is maybe you don't have the crown runout or where the slope is at 0%. All right, now you cannot add that if it is not already part of this table. What you can do is you can come into any one of these control lines, and in this case this is my left control line, and I can right click and I can insert a point. Now, in order to get to that context sensitive menu, I have to actually right click over the line, and then I will get more information or more context sensitive options here. I have the ones that I had before, and then I also have the edit the control line itself, and that's editing its name. Or I can right click and insert a point or add a point if I was adding it to the beginning or end of the control line. Now from here I can see I can dynamically drop in a particular line. Now I can have it snapping to cardinal points, superelevation points. Alright, if I want to add that point in here, I can go ahead and hit and right click to, or left click, I'm sorry, to add, and then right click to finish. Alright, now I've added this point. If I double click it, you'll see that it has given it a name, again the station, a particular cross slope, and it is undefined. So if I was trying to create that crown run out scenario, or I wanted it at 0 or a particular point that needed maybe for a shoulder down the line, I could leave it undefined. I can also put a constraint on it, and the most common would be the vector offset. And I want to make sure I have a constant linear slope or linear transition from one to the other. So I could go ahead and put in 0 for that, just as you do in a template, and I could define it that way so that it is a linear transition between them, and then I can set, I want to know when that is at 0%, say. So I'll click that and it will change the station, if you notice that, and I'll make it change to 1.5, and once I hit apply, you'll notice it changes the station and it changes the point name. So you must hit apply and then it will change that. So if I'm going to put that back at 0 for a minute, and then I'll hit apply, and you'll see that it moves the point and it moves the point name. Alright, so this is a great way if you're doing your shoulder transitions or you need to make sure you hit those points at 1% or 3% or 5%. That's a great way to identify those, is by using this vector offset constraint and then an undefined. Alright, so that's how you can add a point. within your superelevation transitions if you need to. All right, so I can go ahead and you can also delete. I can delete the vector offset. I can delete the point, and so on. So you have all those types of options again here in this bottom window, again with those context-sensitive menus. All right, so this menu down here can often get cluttered when you start adding multiple sections or you're adding your shoulder control lines, and so you want to be able to clean this menu up. The same as we have in the upper right window, if I right-click and I hit the Superelevation display list, I can choose what Superelevation control line I want to see at any given time. So this is very helpful a lot of times when I'm doing a shoulder superelevation control line, because I want to see the main line that I'm going to be referencing and then the superelevation control line for the shoulder. So speaking of shoulders, as I said, it's possible to create a single superelevation control line for transitioning shoulders to meet the MDOT standards. Again, you're going to need one per side. One for the right side, one for the left side of your template. So by right-clicking in this dialog, I can create a single control line. All right. Now with the superelevation control line, creating a single control line, I can call it shoulder, right? And again, a lot of times in the parent section, you want to give it a parent section, and you want to that means you want to tie it to a particular set of superelevation control lines. So by giving it a parent section, I'm saying this is part of the superelevation control lines that I've already put together. All right. If you don't give it a parent section, then a lot of times it can be lost in the shuffle, especially if you have multiple sections. All right. Now you can import a graphic. Okay, so you would not copy anything. You can input type would be a graphic. You can input it from a table, and when you do the table mode, you can either type in each superelevation station cross slope and type for your shoulders. You can also import, and it's looking for an Excel file. All right, you can import an ASCII or an Excel file. All right, you have two different text file or an Excel file, and to understand the type and format of those, if you hit the Help key, it will tell you then the format that is necessary for those. All right, so in the ASCII format, it must be in the format of station, left slope, right slope, and that's got to be in the first 3 columns of the sheet. If you're bringing it in from Excel, it's got to be in the station and cross slope in the first 2 columns of the sheet. So if you did your superelevation calculations for your shoulders or whatever in a spreadsheet, you could then import those directly and you wouldn't have to hand type them. All right, so that's one method that you can bring it in. As I said, you can graphically. If you're going to do the left shoulder, all right, so if I'll say shoulder left, and then I could copy the graphic of my superelevation control line for the left edge of pavement, all right, which is always a handy thing to do because I get all of the same transitions and the transition stations and that kind of thing if I copy, which is typically what I want to do for a super on a shoulder. I want to be able to mimic somewhat of what's happening on the main line edge of pavement. All right, now when I do that, then I can either copy all the original values and it was just going to recreate whatever was going on, or I can say don't copy it, give me a normal crown of 4% because that is my normal crown for my shoulder, and then the maximum superelevation cross slope is going to be whatever the maximum superelevation rate you have for the roadway. So if I'm at 6.9, then that would be my maximum superelevation cross slope. And there will be some cleanup when we put this in this way, but it does then move things to that maximum slope as needed. All right, so once you do that and I'll hit OK, it will create a superelevation control line called that shoulder left. All right, and if I zoom out a little bit, you'll see that it has moved all of mine up at that maximum 6.9% rate. All right, that's one way that works. All right, then I would go through and edit and move things around accordingly. Now, if I didn't like that, I can just delete that control line, and I can hit yes. Again, you can create, again, that single control line, and we'll call it shoulder left. I'll put my parent section back in. I'll do a graphic. I will copy it, and I'm just going to copy my original values. All right. And again, if I wanted to create, and this is an option you have too, if you want to create your superelevation control lines for your edges of pavement, all right, in which case maybe you have them all in a spreadsheet to start. You could come in and use the table method, right, and it wouldn't be shoulder, it would be edge of pavement. You can import those from an Excel spreadsheet, all right, directly, and this wouldn't be shoulder, it would be your edge of pavement 1, all right? So then when you bring in the second one, and I'll go back to graphic, you could say mirror, all right? And by mirroring, what that does is it flips everything around. So now you have your opposite edges of pavement. So things that are positive are now negative and so on. So this is one way to create your superelevation control lines without using a table. If you've already calculated them in a spreadsheet and you just want to use your spreadsheet values, you could import them for the right side and then import them for the left side mirrored. And that works that way. Or you can just, or I say you import them from the right side and then mirror that, or you create a spreadsheet that has the right side transitions and the left side transitions, each in a separate spreadsheet, and you import them directly. All right, one thing I don't recommend though is to use a wizard a second time just for your superelevation shoulder transitions. All right, those typically that doesn't work very well. For the shoulders, I always create, as I said, that create my own superelevation control line, and then assign that to the appropriate shoulder point in the point control dialog. All right, so let me show you that really quick. First, we'll go ahead and I'll hit mirror and I'll add that in. So right now it's the same as the original. All right, so I'll go out to normal view very quickly, and I'm going to go out and navigate to a section that has the shoulder in it, as we do here. I'm going to use my point controls, and I will come out here and I will select my point. Now I can use the radio button, and I will pick my edge of I did the left, so I'll do my edge of paved shoulder. Actually, I'm going to do not an alignment. I'm going to do a superelevation. My superelevation control line is going to be shoulder left. My reference point's always going to be my edge of pavement. When you're doing a shoulder, you're always going to want to pick the edge of pavement that's adjacent to it. And then I would hit add, and you'll see here that it has now superelevated that shoulder. Now, of course, we would have to do editing because you don't know it's at this particular superelevation rate of 2%. This would not be the correct slope. However, you get the point. Now, I want you to pay attention to the aggregate shoulder. You'll notice that I applied the superelevation to the paved shoulder, but the aggregate shoulder followed it. And that's because, using a particular methodology that I have, when I create my aggregate shoulders, and I'll bring my aggregate shoulder out, I always set up this aggregate shoulder so that it has the vector offset. All right, you notice if you take a look at any of my templates, you'll see that I have my aggregate shoulders always set to be a vector offset of the paved shoulder slope of 0. And the reason is that this aggregate shoulder rarely ever superelevates differently or slopes differently from what the paved shoulder is doing. So I always set my templates, and I recommend that you set your templates with that aggregate shoulder following the paved shoulder. Otherwise, you would have to do 2 superelevation control lines, or not 2 control lines, but 2 callouts. You'd have to call out the point for the paved shoulder, and you have to call out the point for the aggregate shoulder. So by making this superelevation, the shoulder be the vector offset, it just saves a little bit of work in Roadway Designer. All right, so likewise with the subbase. All right, again, I want you to keep in mind that a superelevation control line can be applied to any point in a template, any point, meaning that it can also be applied here on the subbase line. So in the case of this superelevation, I could leave it sloping as it is right now. It was set to a 2% slope, a fixed slope. All right, but I could make that point, again with the point controls, if I pick that that particular subgrade point, and again I do a superelevation mode, and I could pick whichever one I wanted, and then I would pick the reference point being my edge of pavement point, and I can apply that superelevation control line to that point down there. Okay, so again, you can set a superelevation control line on any point in that template. So in your subbase conditions, a lot of times I will set my template to have the 2% slope, or maintain that 2% slope, and not be set at a particular depth dimension. Unlike the aggregate base or some of the other parts of the cross section where you want to hold the depth of those layers, essentially. So in the subbase, a lot of times I will make under my shoulders be 2% and not be vector offsets or set to a particular vertical depth from the aggregate base, because I know I want the subbase, in a lot of cases, to superelevate differently than the main line above or from the materials above. All right, so by creating superelevation control line, or even using a superelevation control line from a particular station range for the shoulder, I can create the various shoulder sloping or subbase sloping conditions under the shoulder that we require, and a lot of times in our cross sections, our pavement cross sections that we show on our plans. So instead of creating a lot of complicated templates that have many different sub-base type conditions and then having display rules to turn all of those various conditions on and off, I can use the same template or one template and then manipulate those points on the sub-base in order to, or the subgrade depending, to mimic the real world scenario we're trying to construct, where I can control any of these points on my sub-base material very easily with that with any superelevation control line. I can assign any one that I want from a particular station range to another particular station range, and I can achieve the same results much easier than a very complex template with many different subgrade options loaded into it. All right, one more thing on the superelevation display. Again, you'll see here, and if I zoom in, the left and the crown and the right range points, those you cannot edit those in the section. So if you need to change those particular range points or to see them differently here in this dialog, the only way you can do that is actually to delete the section and then redo the superelevation control lines. However, you can always change the points, again under that point control menu. You can always change the points in which they're applied. So if for some reason you realize, oh, I want to add that to a widening section that's a different edge of pavement, you can always come in and add that by adding the point and then adding the necessary superelevation control line to it. So keep in mind that while you can't change the range point dialog per se, you can't change this in the dialog or what's called the particular range points. You can continue to assign superelevation control lines, even the same superelevation control lines, to several different points. That was a quick look at point controls and superelevation in Roadway Designer. For some hands-on training for MDOT staff and those with access to Bentley Learn, try the course Road Fundamentals using Geopack, which will cover many of the topics that we went over in this webinar. There is also some supplemental training material available in ProjectWise. MDOT staff, please email the MDOT Powered Geopack support email address if you need help locating it. This concludes Part 3 of the Roadway Designer series. Thank you.